right, good morning, everybody at home. Can I get a thumbs up that you hear me and see the board okay? All right, well, hopefully this will be our last day in section 1 with the inverse sine, cosine, and tangent functions. At the top, I just put all of the important information in writing for you guys so you have it all in one spot as far as what the inverse sine, cosine, and tangent are capable of, that there are ratios going in, and then there are only certain angles that are capable of coming out of them, okay? I am a big fan of these charts. I draw them all the time. Every time I'm doing a problem, this is what I picture. So just to kind of review with you one more time, if you are dealing with the inverse sine, he's only capable of spitting out angles right here on our unit circle, from pi over 2 to negative pi over 2. Those are the only angles and ratios that survive the cut of its graph to make the inverse exist. All right, we got the inverse cosine. He behaves a little bit differently. If you are working with the inverse cosine, this function is only capable of spitting out angles between 0 and pi, quadrant 1 and quadrant 2 angles. These are the only angles and ratios that survive the cut of the cosine's graph to make the inverse cosine exist. All right, then we got the inverse tangent. He behaves kind of just like the inverse sine. The angles that survive the cut of his graph are angles from pi over 2 to negative pi over 2, quadrant 1 and quadrant 4 angles. And again, I'm not saying any angle in quadrant 1 or quadrant 4 because we know that you can keep rotating around and create more angles that land in these quadrants. It literally has to be an angle between 0 and pi over 2 or 0 and negative pi over 2. So if you rotate all the way around this way to get to a quadrant 4 angle, that quadrant 4 angle doesn't count. All right, you're only working with the ones from 0 to negative pi over 2 or 0 to pi over 2. All right, and then we have this cheat chart where we have seen if you take the inverse sine of a positive ratio, the answer to that is definitely a quadrant 1 angle. If you take the inverse cosine of a positive ratio, the answer to that question is a quadrant 1 angle. And if you take the inverse tangent of a positive ratio, the answer to that is a quadrant 1 angle. So if you take the inverse trig function of any angle, of any ratio, guys, it should belong in quadrant 1. That's going to spit out a quadrant 1 angle. Then we saw if you took the inverse sine of a negative ratio, again, between 0 and negative 1, you're going to get a quadrant 4 angle. So you'd want to put that angle or draw that triangle in quadrant 4. If you take the inverse cosine of a negative ratio, then that's the one that spits out a quadrant 2 angle. So you'd want to put that angle or put that triangle in quadrant 2. And then if you take the inverse tangent of a negative ratio, it's going to spit out a quadrant 4 angle between 0 and negative pi over 2. So you'd put that angle or you'd put that triangle in quadrant 4. So this is everything that I think you should be able to use to solve or work with these inverse trig functions, all right? Okay, I'm actually going to skip this problem. I'm going to go to the equations first. I feel like they're a little bit more important. So if you don't mind, I'm going to skip question number 1. Let's go to the equations. Let's do them first. Okay, so our job is to solve the following equation. So guys, remember, sine and inverse sine are inverses of each other. One will undo the other. So if you need to get rid of an inverse sine, we have the sine function that will get rid of it. If you have to get rid of the sine function, we have the inverse sine that will get rid of that function. They are going to cancel each other out. All right, so our job is to solve this for x, right? Right now, that x is stuck inside of the inverse sine function. So our main goal right now should be to get the inverse sine by itself. So I'm going to divide both sides by 3. And I'm left with the inverse sine of x is equal to pi over 3. So guys, think about it. The inverse sine of some ratio is going to equal the angle pi over 3. So we have to figure out what ratio is missing from this equation, right? Well, now that I've gotten the inverse sine by itself, guys, technically, to get rid of the inverse sine and get x by itself, I can sine both sides of the equation. So the sine and the inverse sine cancel, and I'm left with just x. And my answer will be whatever the sine of pi over 3 is. And the sine of pi over 3 is going to be a ratio. An angle goes into the sine function, and a ratio comes out. So guys, think about it. Pi over 3 is a quadrant 1 angle. All right, you're taking the sine of a pi over 3. Guys, that's a 60. So give yourself a triangle in quadrant 1 with that reference angle of 60 degrees. And now we know what? This is root 3 to 1 to 2. What is the sine of pi over 3? Well, guys, sine pi over 3, sine 60, is root 3 over 2. It's O over H, it's Y over R. The answer to this is root 3 over 2. And it's definitely a positive ratio to create that quadrant 1 angle. And you're done. Okay? Does everybody feel okay with that? All right. All right, let's go to the next one. This one obviously looks a little bit busier. In reality, we're solving this for x. X is stuck inside of the inverse tangent function. And I have more than one inverse tangent function right now. So right now, let's work on getting the inverse tangent function by itself. So x is stuck inside of that function. X is stuck inside. -5 is times the tangent function. But this minus pi over 3, he's not part of what's inside the inverse tangent. They would have had to put parentheses around that if he was part of what's inside. So right now, he's kind of just hanging out by his own. Let's add him to the other side. Let's start moving stuff away from this inverse tangent function. All right, so now I'm left with the inverse tangent of x minus 5 times the inverse tangent of x. It equals, guys, 2 pi over 3 plus 1 pi over 3 is 3 pi over 3. 3 pi over 3 is pi. Now, guys, this is 1 inverse tangent x, and this is minus 5 inverse tangent x. Those are like terms. We can put them together. If I had one of them and I took away 5 of them, I really have -4 inverse tangent x's. All right, and again, we're going to keep going. Let's get this inverse tangent by itself. So let's divide both sides by -4. So now we have the inverse tangent of x is going to equal -pi over 4. So the inverse tangent of what ratio is going to get you an angle of -pi over 4? Well, guys, let's undo the inverse tangent. Let's tangent both sides. And my answer will be x equals whatever the tangent of -pi over 4 is. Well, guys, -pi over 4 is -45 degrees. -45 degrees is definitely an angle that landed in quadrant 4. So you can give yourself a 45-degree reference angle in quadrant 4. And what do we have? 1 to 1 to root 2. But hold the phone. In quadrant 4, guys, this is a positive x value, but this is a negative y value. So don't forget the signs. All right, and now what is the tangent of that 45-degree angle? Tangent is O over A or Y over X. It's -1 over 1, which is -1. The tangent of -pi over 4 is -1. And guys, another way to do these problems, if you don't want to draw the triangle in the actual quadrant, then you could just say tangent -pi over 4. To find the tangent of -pi over 4, guys, that's going to be the tangent of a 45-degree angle that landed in quadrant 4. And then you could say, all right, what is the tangent of pi over 4? Give yourself a triangle. It's 1. All right, but what would the tangent of an angle be in quadrant 4? Then you can use your all students take calculus. In quadrant 4, only the cosine ratio is positive. So the tangent of an angle in quadrant 4 would be a negative ratio. So you don't have to draw the triangle if you don't want to. This is how we were doing it in the beginning. We were turning this into the tangent of the reference angle, but what quadrant were you in? I'm taking the tangent of pi over 4, but I'm really in quadrant 4. So you get your ratio from the triangle, and you can get the positive or negative sign from all students take calculus, whichever one works for you. All right, let's try the last one. The last one has a little bit of a hiccup because technically there's a period change that would have happened to this function, and I'll explain that in a second. Oh, I wish I didn't erase that, darn it. Oh well. Now slow down, Michael, see? Should have left that up for another second. All right, last equation. If you notice, all the other equations that we were solving, it was, the first one I think was inverse sine, the inverse sine of x. The second one was the inverse tangent of x. This is the inverse sine of 3x. You're not just taking the inverse trig function of x anymore. This one has something else stuck inside of that function. So guys, if you remember, when you put something in there with x, that could potentially affect the period, the amount of inputs it takes to create that change. So this could be a little bit different to solve. All right, but let's just stay with the beginning. Same thing. Stay with your goal. Let's get the inverse sine by itself. All I got to do is divide by -6 to make that happen. Because 3, I can't get to. He's inside that function right now. Okay. So now we have the inverse sine of 3 times x is equal to -pi/6. Remember, our goal is to solve this for x, but right now we're working with 3 times x. So to be very technical, you could use a u substitution here. So you could say, normally I'd want this to just be the inverse sine of x, right? One single component. So let u equal 3x, and just put a u in its place for now. So now we're going to have the inverse sine of u equals -pi/6. Okay. So guys, now it's a little bit more normal, right? The inverse sine of what ratio equals that angle, okay? Well, in order to solve this, we would sine both sides. Let's undo the inverse sine function. So we would sine both sides, and you get u is going to equal whatever the sine of -pi/6 is. So now you have to find out what is the sine of -pi/6. What ratio is that? So guys, you have two options. -pi/6 is a 30-degree angle that landed in quadrant 4. So give yourself an angle that landed in quadrant 4 with a 30-degree reference angle. Now you can draw your triangle, right? This would be what? 1 to √3 to 2. But we're in quadrant 4, guys. So this would be a positive x, and this would be a negative y, and your hypotenuse or radius is always the positive number. All right, so now, what is the sine of a negative 30-degree angle? Sine 30 is O over H or Y over R. It's -1/2. The answer to that is -1/2. Or another way to think about it, sine -pi/6 is like taking the sine of pi/6, but you're in quadrant 4. So then you could use your triangle. What is the sine of a 30-degree angle? It's 1/2. But then according to all students, take calculus. What is the sine of an angle that landed in quadrant 4? Only the cosine ratio is positive for angles in quadrant 4, which means the sine of an angle in quadrant 4 would be negative. So whether you want to do it like this or whether you want to do it like that, the answer is -1/2. Okay, but here's the problem. U is not who we were solving for. We were trying to solve this problem for x. So now that you finally solved it for u, now it's time to put what u is equal to back into the problem. So now it's not u that equals -1/2, it's actually 3x that equals -1/2. And now you have to solve this for x. Now how do I solve for x? Well, I got to divide by 3. I got to get x by itself. So because I'm already working with a fraction, instead of dividing by 3, I'm going to times by 1/3. So then when I times by 1/3, it's actually, x needs to be -1/6 to make this true. Because this way, when you plug -1/6 in, it actually becomes 3 times -1/6 is the -1/2 that we needed to make this equation true. So the answer is -1/6. Do we feel okay with the equations? Again, right now, these are pretty simple, basic trig equations. We will have, I think, in 2 sections, either section 3 or section 4 is devoted to trig equations. We might get into some more complicated ones there. This is just pretty basic right now. Is everybody all right? We good? Okay. At home, thumbs up, we're all right? All right, let's go back to that first problem, and then we're good to go. Okay, in this problem, it says, find the inverse function, f inverse of f of x equals 2 times sine x minus 1. So we're trying to come up with a function that will undo this function. So guys, it only makes sense that if this is a sine problem, his inverse would involve the inverse sine function, okay? And they're telling you right now that as far as this function is concerned, this is who you're allowed to plug into it. Angles from negative pi over 2 to pi over 2. So he comes with a written domain. We already know the domain of f. The original function is negative pi over 2 to pi over 2. I'm just going to write it in interval notation instead of inequality notation. All right. Well, guys, the range is usually easiest to find. I'm going to find his range right now because I know they're going to ask for it in the next question. The range is usually easiest to find when you're looking at his graph. So you can see, all right, well, what y values come out, right? Well, think about it. The original sine function has a range from negative 1 to 1. The original sine function only spits out angles from negative 1 to 1. All right, that's the original range. All right, but obviously, guys, this function has been transformed. It's not just the sine of x anymore. It's 2 times the sine of x minus 1. So he's going to have a newer range depending on those changes that you've made to his graph. So guys, the range is the y values. So any changes you made to the y's in this equation are going to affect the y's in his range. So guys, the good news is x hasn't been touched. So it's not like I've changed his period or the number of inputs that have to go in. I haven't shifted it left or right or anything. X hasn't been touched. All of the changes to this equation are on the outside. It's 2 times the y's, and then the y's minus 1. It's causing a stretch and a shift down. So it's 2 times the y's and the y's minus 1. Well, guys, if these are the original y values, start and end basically, just make those changes here. So what would happen to a negative 1 if you times it by 2? That would have made it negative 2. And then if you minus 1, it would have made it negative 3. So now that y value has shifted to negative 3. And then 1 used to be the other end of his range. It used to stop at 1. Well, what if you times 1 by 2? Now you're at 2, but if you minus 1, you're back down at that 1. So his new range is from negative 3 to positive 1. And again, there's other ways to find the range. That's just what I do to find the range without having to look at his graph. All right, so guys, the hard part to me is over. Everything else is easy now. If I actually want to find his inverse, well, think about how we find inverses. Inverses, your x and y's have to trade roles, right? These x's become the inverses y's. These y's become the inverses x's. So take your original function, which is y instead of f of x, equals 2 times the sine of x minus 1. We have to switch x and y, and then we're going to have to resolve it for y. That's how you find inverses. You switch the roles of x and y. All right, so let's switch x and y, and it will be x equals 2 times the sine of y minus 1. Guys, remember, this right here, that is the inverse function. He's just not in the correct form. That is the implicit version of the inverse. We want the explicit version of the inverse, which means we have to solve it for y. You want y to be who comes out, and you want x to be who lives inside. So let's solve this for y. All right, let's add the 1 away. All right, if I want to solve this for y is stuck inside of the sine function. I got to get the sine function by itself. Divide by 2. And now how am I going to break y out of the sine function? How am I going to undo the sine function? I'm going to inverse sine it. And now y will equal, I'm just going to do a little flipperoo, equals the inverse sine of x plus 1 divided by 2. And there's your inverse, except we're going to write it as f inverse of x equals the inverse sine of x plus 1 divided by 2. All right, so there's our inverse. So we did part A. Part B says, find the range of f. Guys, we found the range of f. The range of f was -3 to 1. We found out what that new range was going to be. So we have the domain of f. That came with the problem. We found the range of f. Now they want the domain and range of the inverse. Well, remember, your domain and range is just Trig. His domain is the inverse's range. His range is the inverse's domain. So now we know the domain of the inverse is going to be whatever the range of the original one was, which was -3 to 1. Right? Those are the ratios that we'll be able to plug into the inverse sine function. And the angles he is capable of spitting out will be what was the domain of the original? -π/2 to π/2. So that'll be the range of the inverse. All right, and you're good to go. Do you guys feel okay with that? Yes? Yeah, okay. At home, thumbs up. Well, look at that, guys. I got through all the problems and I got 5 minutes to spare. All right, does anybody have any questions? Are you guys okay? Okay, so that is the end of section 1. We did it. We got through it. When we come back from our 3-day weekend that I think will be much needed for everybody, we will start section 2, which will still involve the inverses, okay? Guys at home, let me double check your attendance. If you don't have any questions, you guys will be good to go. Guys, there is a homework on this. It's 5 questions. It's really short. So yesterday's homework on the inverse tangent and these problems on the equations, they're going to be due Monday night at 11:59. So I've given you the whole weekend to get yesterday's problems, and today's problems done. And I believe your inverse cosine questions are due tonight, maybe? I think. All right. So make sure you check and look at your homeworks that are assigned. Everything that is assigned is due Monday at this point. Okay. All right. Let me see the attendance.